Good afternoon, ladies and gentlemen. In this short video, I'm going to be doing the practice problems for section or practice D, as in dog, for chapter 18. And the topic is current and potential difference across a resistor. So we're going to look at a bunch of electrical circuits and have to figure out how much voltage is across a resistor and how much current goes through the resistor. All right, so we'll start with number 25, and this is on page 668. So we'll look at this circuit, and we see a 12-volt source. So that is a power supply, okay, something that's providing 12 volts. Maybe it's a battery. We have 12 volts in series with this 3 ohm resistor. I'm following along this way. And then I realize, oh, these two resistors are in parallel. So this 6 ohm resistor and this 9 ohm resistor are in parallel. So right away, I recognize that 6 ohms here is in parallel with 9 ohms. Okay, I recognize that right away. And then I remember, oh, that means that the total resistance or the equivalent resistance of this 6 ohm and 9 ohm, we're going to call that 1 over R. The 1 over equivalent resistance, just over the 6 and the 9, is equal to 1 over 6 plus 1 over 9. All right, so let's look at that. Do I have could do the common denominator, but I'm just going to do 1 over 6 plus 1 over 9. That gives me 5/18. So this is equal to 5/18. So I take the reciprocal to figure out what the R equivalent is. I'll put here. So the R equivalent is equal to 18 over 5. So give me the reciprocal of that. It says 18 over 5, which is equal to, hit the button here, 3.6. So it's equal to 3.6 ohms. So if I were to take a multimeter across this point and this point, and see if you guys can see this point right here, one lead here and one lead there, I would see a 3.6 ohms. If I take it across the 6 ohms, from here and here, it's 6 ohms. From here and here, it's 9 ohms. But together, when they're in parallel, you always end up with something smaller. It's 3.6 ohms. So I'm going to redraw this whole circuit. I'm going to redraw the whole circuit. So I have a 12-volt battery. Oh, it really should be like this, plus and a minus inside, and then 12 volts on the outside of it. Okay. All right. Sorry, it's not drawn very well here. Let me start again. All right, so I'm going to have a 12-volt battery in series with the 3 ohms. And that is in series with this 3.6 ohms. 3.6 ohms. If I look carefully, I notice that the 3.6 ohm resistor and the 3 ohm resistor share a node. Well, if that's the case, then they're in series with each other. Okay, so the 3.6 and the 3 ohm resistors are in series. If they're in series, we just add them up. So that's the same thing as, I run out of room here, the same thing as a 12, I did it again. There we go, 12 volts, and I'm going to just add them up. Here, add 6.6 ohms. All right, so that's pretty messy, so I'm going to try again here. So what do we just do here? Well, we immediately recognize that the 6 and the 9 are in parallel. So these two together, the whole thing looks like a 3.6. That just looks like a 3.6 ohm resistor. Why? Because 6 ohms in parallel with 9 ohms. When we figured that out, the equivalent resistor was 1 over 6 plus 1 over 9, which came out to 5/18. So therefore, that equivalent resistor is 18/5, which is 3.6. So I'm going to redraw this a little bit nicer. I have my 12-volt battery here in series with the 3 ohm resistor. And this looks just like a 3.6 ohms. So hopefully here you can go, oh, I see that these two are in series. And if they're in series, we just add them up. So 3.6 ohms in series with 3 ohms, we just add them up. So that our equivalent is just 3.6 plus 3, which would be 6.6 ohms. So now I'm going to redraw this. And I have my 12-volt battery, and the 12-volt battery, it doesn't know how many resistors are there and which ones are in parallel, which ones are in series. It just sees a 6.6 ohm resistor. That's all it sees. Okay, so if I were to take my leads of my multimeter on either side, even here, if I did it here and here, this voltmeter, or sorry, this battery thinks that there's just a 6.6 ohms. That's all it sees. Okay, so now the question is, how much current goes through here? All right, I know exactly how much voltage is across the 6.6. How do I know that? Because this node and this node is the same. This node and this node. So why don't I draw it so it really looks like they're parallel to each other? So I have 6.6 ohms in parallel to this battery of 12 volts. Now maybe it looks kind of obvious that the voltage across the 6.6 ohms is 12 volts. Okay, because this node and this node is exactly the same. We're going to assume that the resistance in the wire is negligible, almost zero. Well, if that's the case, now I can figure out how much current is going through here. How much current is going through here? How do I know that? Well, I know the voltage across here at exactly 12 volts. I put the positive on this side because the positive in the battery is the same node. All right, so I have V is equal to IR. And so my current is the voltage divided by the resistance. And this is my equivalent resistance, the whole circuit. How much current is really being supplied by the battery? Okay, so I have 12 volts divided by 6.6 ohms. What is 12? It's going to be less than 2, right? 12 divided by, oops, I'm trying to clear it. Okay, 12 divided by 6.6. I have 1.81818181818181, etc. Okay, amps. That's how much current I have. All right, so we know that I have 1.8 amps coming from the power supply. So that's what we're going to start with here. We could say 1.82 amps is the current. All right, so now let's go back to the original circuit. Let's go back to the original circuit. See if I can get a different color here. I know that I have exactly from here 1.82 amps. So from here I have that the current is 1.82 amps. Well, if that's the case, that's how much was going into the battery. So in the battery, out the battery, 1.82. Put here, same I, 1.82. Notice that that's next to the 3 ohm resistor. So if 1.82 current amps came out of the resistor, that's exactly how much went into the resistor. Same I. Same I. So I know that the current that went through this one is 1.82 amps. 1.82 amps. So if I know that the resistor here is 3 ohms, how am I going to write this? I'm going to have to write here. On this side right here, V is equal to IR. So the question is, how much voltage drops as the current goes through the 3 ohm resistor? So I'm going to say here the voltage for the 3 ohm resistor, I'll call it R3, this one here. All right, so the current is 1.82 times the 3 ohms, times the 3 ohms. I'm going to keep that there and say times 3, times 3. There we go, 5.45. So I know that the voltage through here is exactly 5.45. Let's see here, right here. 5.45 volts. Okay, so we're going to say here that the voltage of the 3 ohm resistor is equal to 5.45 volts. You know what the current is going through it. It's 1.82. Okay, so now the question is, what's the voltage across these resistors and how much current is going through them? So what's important to remember is when you have resistors that are in parallel, the voltage across them are exactly the same. So whatever the voltage is, I hope I'm drawing this right with the plus minus. Put here plus minus, plus minus. Current goes, yeah, plus minus. So whatever the voltage is across the 6 ohm resistor, it's going to be the same thing as the across the 9 ohm resistor. So here's what's interesting. If I have 12 volts from the battery, which I'm going to make pink here, 12 volts from the battery, and 5.45 volts was dropped from this resistor. Remember, this you can look at it just as a clump, these two yellow ones. How much is left over? Well, you only have 12 volts. That's all you have total in this circuit. So all I have left if from here is 5.45. What the voltage across this will be whatever 12 minus this is, because some of it was used up here and the rest is dropped across these two resistors. Okay, so let's take this. I'm just going to leave that there and say minus 12. I know that I don't want negative. Okay, 6.54. So right here I have 6.54 volts. Okay, let's see. 6.54, clear, 6.54 plus 5.45. That's pretty close to 12, because we're rounding up, is 12 volts. So notice the battery is giving the total voltage to the circuit. So 5.54 volts is dropped across this resistor. So across these resistors, it's the remaining. It'd be 6.54 volts. All right, now the question is how much current? We notice that this current is going around here. So it went through this resistor. It's 1.82 ohms. It goes through this power supply or battery, and then it gets here and it splits up. Some of the current goes here, and some of the current goes here. When they go through here, they add up and they come out, and we know it's 1.82. So we know the sum of the current that goes through the 6 ohm and the current that goes through the 9 ohm is going to equal 1.82 amps. But how much current goes through it? Well, we go through the same thing. I know that V equals equal to IR. So the current is the voltage over the resistor. Well, I know the voltage across it is 6.54. So the current that goes through the 6 ohm will just be 6.54 divided by 6 ohms. Divided by 6 ohms. So let's do that. 6.54, this is getting kind of messy. Divided by 6 ohms. That'll be this one here. That's the current through the 6 ohm one. I'll put the I sub 6. So what do we have here? I've got 6.54 divided by, 6.54 divided by, I gotta hit the right button, divided by 6. I get 1.09. Okay, so I know that from here I have 1.09 amps. That's how much goes through there. Now I could just take 1.82, subtract 1.09, and that gives me the current going through here. Could do that because they have to add up to the 1.82. Or I can do the same thing I did over here. So I'm going to go that the current through the 9 ohm is the voltage over the 9 ohms. So that would be 6.54 volts over the 9 ohms. Let's do that. 6.54 divided by 9. I get 0.73. See that? 0.72666666. 0.73 amps. So here I have going 0.73 amps. Now when I add it up, let's see what happens when I add it up. Add that to the one above it. Right there, enter. And I get 1.82, which is exactly what came out. All right, so let me break that down for you because we just figured it all out in this circuit. The current going through this 6 ohm is 1.09. Right here, there's the current. And the current going through this, resistor, hope I said resistor, the 9 ohm, is 0.73 amps. 0.73 amps. When they connect, the currents add up and the current comes out and it's going to be 1.82. And we did prove that. So now we just figured out exactly how much voltage is across each of the resistors, and how much current is going through each of the resistors. And how do we do that? Well, we had to figure out first the equivalent resistance. How much resistance does that battery see? and all it sees was a 6.6 ohm resistor. And that's how we start with how much current comes out of the battery or the power supply. And we rounded it up to 1.82. So then we go back and take that juicy bit of information into our original circuit. I know that 1.82 is coming out, going in to that battery. And I notice that this 3 ohm resistor is right next to it. So that's how much current went through it, because the current just goes right through the resistor. Well, once I knew what that is, I can do V equals IR and figure out how much voltage was across here. It was 5.45 volts across this 3 ohm resistor. So I have 12 volts here. I have 5.45 volts. The remaining amount of voltage had to be across these two resistors that both have the same voltage across them because they are in parallel. So hopefully in the classroom, you guys are going to be able to take that multimeter and measure for yourself what the resistance is. You learn how to put your leads to measure the voltage would be the same thing. So once we knew how much voltage is across these two resistors, then we use V equals IR to figure out what the current, I equals V over R. I know that the voltage was 6.54, I divided it by 6, and I got 1.09 amps going through this resistor. So I could have just taken the 1.82 and subtracted 1.09 to figure out how much current went through the other resistor. Or I could have used the same voltage over that resistance. We took the 6.54 volts and we divided by 9 ohms. This is ohms here. And that gave us 0.73 amps. So we figured out for each resistance, the potential difference, which is the same thing as voltage, and the resistance. All right, let's take one that's a little bit bigger circuit. Let's look at this one right here. The next one, number 26. They want you to know, okay, here they're being specific. For the circuit shown below, determine the following. How much current goes through the 2 ohm resistor? So they just want to know how much current goes through this guy right there. And then they want to know the voltage difference. What's the voltage difference across the 2 ohm? Oh, and they also want to know what the voltage drop. It's another way to say voltage difference across the resistor. And then they want to know the voltage difference across the 12 ohm resistor. So that would be this one right here. How much voltage is across the 12 ohm resistor? And they want to know the current going through that. And that's it. That's all they want to know. Well, it turns out that we still need to know how much current is going through this battery. And the only way we know how much current is going through this battery is to figure out what is the equivalent resistance of all this we see right here. Once we know what the equivalent resistance is, then all we have to do is for V equals IR equivalent, the current is just that voltage divided by the equivalent resistance. So we want to figure out what the equivalent resistance is. We'll put that denominator, we'll put 18 volts, and then we'll know how much current is coming out of, the longer one is the plus, the minus, how much current is coming out and how much current is going in. Because that would be the same, current doesn't change there. All right, so let's take a look at the circuit. First thing I notice, let me see, I'll use pink here. I notice that this 6 ohm resistor and this 6 ohm resistor, they're each in parallel to each other. And hopefully you've noticed that when you have resistors that are in parallel, exactly the same magnitude resistance, then the equivalent resistance is half. How do I know that? Well, let's see here. I'll put 1 over R equivalent is equal to 1 over 6 plus 1 over 6. All right, I happen to know that's 2 over 6. 2 over 6. And so I take the reciprocal is 6 over 2, which is equal to 3 ohms. So immediately I see that these 6 ohm resistors are in parallel. Notice that they each share the same node. So I want you to squish those down in your mind, and that's a 3 ohm. And then I go, oh, it's next to this 3 ohm here. So let's redraw that. Okay, I'm going to turn the page here. I started to draw here. There we go. There's mine. So I notice that these two are parallel. Okay, let me grab a different, let me go ahead and say, I'm going to make it a yellow box. So for all intents and purposes, this guy right here is the same thing as a 3 ohm resistor, the parallel group. And oh, I noticed that these two are in parallel also. So let's take care of those. Let's figure that out. 1 over R for this one is 1 over 4 plus 1 over 2. No, it doesn't look like I need a calculator for that one. That's the same thing as 1 over 4 plus 2 over 4. Correct? That's 1/2, which is 3 over 4. So the equivalent resistance is 4/3, or 1.333333 ohms. So that's what this one is. This one right here, this box. Right here, that guy right there is actually looks like a 1.33 ohms. All right, so we're going to go ahead and redraw that for ourselves. I recommend doing that until you've done this 3 times, then you can skip some steps. All right, so I'm going to redraw. First, we'll start with my battery, 18-volt battery. Okay. All right, so what do I have here? I have a 3 ohm. That's 3 ohm. And I'm going to come over here. Okay, I got to split this up here. So on this side right here, I have the 3 ohm. I decided that, yep, those 6 ohms in parallel to each other is 3 ohms. There's 3 ohms there, and it's in series with this other 3 ohm. All right, let's see. What else do I have here? Down here, I have a 1.333 ohm in series with the 2 ohm. That's a 2 ohm. There we go. Okay, you with me so far? So on this one right here, I collapsed them, shall we say, because they're both in parallel to each other, and that's a 1.3 ohm. And this guy up here, I kind of collapsed them 6 and 6. Oh, I knew immediately that's 3 ohms. All right, so then I realized, oh, these 3 ohms and this 3 ohms are in series. So I'm going to write here, these here are in series. And so are these. These are in series right here too. Those are in series also. So to collapse them, or to indicate what the equivalent resistance, I just add them up. Oh, let's see. I can redraw that. Do I have enough room? I'm going to redraw it underneath here. Okay, so I have this 3 ohm resistor. All right, and these things are still split up. So I have 3 and 3. Well, what's 3 and 3? 3 and 3 is just 6 ohms because they're in series. So I have 6 ohms there, 6 ohms. And down here I have 1.33 plus 2. 1.33 plus 2, so I have 3.33 ohms. Okay, so here I have, I'm redrawing it just as a 3.33 ohms. There we go. I'm redrawing my battery here. All right, so that's 18 volts. So I reduce these down to 6 ohms and this to 3.33. And I notice, oh, these are in parallel to each other. So this is where you have to really understand how to recognize that things are in parallel or in series. So I recognize that this guy, these 2 guys are in parallel to each other. All right, so I'll have to figure that out. What is the equivalent of that? In this case here, I've got 1 over 6 plus 1 over 3.33. All right, so let's figure that out. Okay, clear. I'm going to leave it as 4/3, see if that helps. Well, let's just leave it at that. Okay, 6, invert that, plus, I know, I'll do 3.333333. See if that helps. Invert that, there we go. Okay, so this ends up being 0.466667. But I want the inverse, or this is the reciprocal. So what is the equivalent resistor of that? Let's take the reciprocal. There it is, 2.14. Okay, 2.14, yeah, 14 ohms. Okay, so this together parallels 2.14, and hopefully you see that that parallel combination is in series with this 3 ohms. So I'm going to redraw that so that you can see it. I'm running out of room here. Okay, redraw that over here. I have this 3 ohms now is in series with this 2.14 ohms. And that's connected to my 18-volt battery. Okay, sorry, my circle's too big there. All right, so I recognize, this 3 ohms is in series with this parallel combination, which is 2.14, so I just add them up. So this would be equal to, add them up here, 3 plus 2.14 is 5.14 ohms. So I have this simple 5.14 ohm in parallel with the battery, 18 volts. So this whole, let me see if I can unzoom. This whole circuit, this whole big circuit right here that we started with is reduced to what is the equivalent resistor that the voltage supply sees. All right. So once we have that, then we can figure out, well, how much current is going through that battery and therefore into this equivalent resistor. All right, so let's figure that out. So I've got V is equal to I equivalent resistor. So the current must be that voltage divided by the equivalent resistance. So I have 18 volts divided by 5.14 ohms. All right, what is that? Oh, I'm going to go ahead and just add 3 to that. There's my 514. Okay, so that's in the divider part. So I'm going to say, give me the inverse to that, times 18. There we go, 7/2, exactly. And that's why I wanted the more accurate one, 7/2 amps, which is 3.5 amps. Okay, so I know exactly how much, let me go back to this guy right here. I know exactly how much current, it's 3.5 amps, is coming through this power supply or battery. I know it's 3.5 amps, 3.5 amps. Okay, so that means that's how much is coming into it, 3.5 amps. All right, so now I'm going to take this circuit and go the other way around. Let's come through here, and the current is coming up, and it goes through this 3 ohm. We need to know how much voltage is the drop. I know that the current here, the current going in is 3.5 amps. That's the current. So how much is the voltage drop of the 3 ohm? Is this the only 3 ohm? No, I'm going to say this one here, right here. All right, so V equals IR. So the current, oh, it's already, there to get the current. So the V, what is the voltage here? I got 3.5 amps. So V, the voltage is 3.5 amps times the 3 ohms, times the 3 ohms. Okay, so I got 3.5 times 3. There we go, 10.5. So I got 10.5 volts. How about that? So I know that I have 10.5 volts across here. If I collapse this all down, ooh, let's see, we got that right over here. Let's go right here. This is all collapsed down. Okay, see, maybe this would help over here. Probably right, start here. So I just figured out that I have 3.5 amps coming out of here. So therefore, across here, I had, what was it? 3 times 3.5. Wrote it down here. Oh, it's on 10.5. So I have 10.5 volts. There we go. So I have 10.5 volts that got dropped across this resistor here. And I have 18 volts. How much is across here? Well, I have 18. It's got to be 18 minus 10.5. Whatever's left over is left over to these guys. So let's see what that is. 10.5. I want 18 minus that. Minus 18. 7.5. Okay. I don't worry about the plus and minus. I just know that's going to be positive, right? So from here, I have 7.5 volts. Okay. 7.5 volts across the 6 ohm here and the 3.3. All right, now, how do we figure out how much current is going through there? Okay, so again, the current is going to be the voltage over the resistance. So this current, this 3.5, I'm going to write here, 3.5 amps gets split up. There's supposed to be an arrow. Some of it goes up through the 6 ohms. Some of it goes down to the 3.3. But what's really happening? Let's look up on this one here. some of that 3.5 amps split up and goes through the, it's 6 ohms, but really it's through this 3 ohm and then the 3 ohm. Current stays the same when they're in series. The current stays the same. And then some of that current's going to come down here through the 1.33 and then the 2 ohms. Okay, so let's figure out how much current goes through through this branch right here. All right, so I'm going to take the 7.5 volts divided by the 6 ohms. Okay, 7.5, don't worry about the negative there. I'm just wanted the magnitude divided by 6. Okay, 1.25. So I know 1.25 amps. I know that in this branch here, I have 1.25 amps. So if 3.5 was coming into this node and 1.25 went that way, then the remainder must be down here. So whatever 3.5 minus 1.25 is. But let's say you didn't realize that and you just want to do the same way again. So the current in, I'm going to say this is the current through the 6 ohm. The current through the 3.3 is going to be 7.5 volts divided by the resistance 3.3. Let's do that. See what that is. 7.5 divided by 3.3. Oops, I'm not hitting the right buttons here. 7.5 volts, 0.5 divided by, there we go, 3.3. 2.27. So I got 2.27 amps. So I have 2.27 amps. 27 amps. So I had said you could subtract, is that correct still? 3.5 minus 1.25, 2.25. Okay, so we're going to lose things if we're rounding things too much. Okay, you're going to lose things if you round things too much. So this was really 3.33333. Probably would have been better if I kept it 3.33333. All right, so I'm gonna say here 2.2. Well, actually, I'm gonna prove to you guys 7.5 divided by 3. Is that right? There we go. Still 2.25. There you see, huge difference when you round off too much. So we're gonna say it's 2.25. Exactly 2.25. Okay. All right. So again, through here, through this current, I got 1.25 right here, 1.25 amps. And going through this resistor here, the current is 2.25. When they add up, they become 3.5. Make sense? Okay, so let's go back up here. And we know that the current coming up through this one is 1.25. Here it is 1.25 amps, and this one right down here is 2.25 amps. And they were only interested in asking about the 2 ohm and the 2 ohm. So which one is that here with our picture? Oh, I guess I need a new color here. They're interested in this 2 ohm resistor they're asking about, and then the 12 ohm. Oh, shoot. Did I rewrite this wrong? Okay, we got a problem. I wrote 2 here, and it says 12 here. Do that wrong here? Are we doing the same problem here? Yep. Okay, so I see a problem here because it says 12, and I wrote down 2. So we did 4 and 2 instead of 4 and 12. Well, we're going to continue with the 2. I'm going to pretend that this problem was actually just 2. Okay, because I rewrote it incorrectly. Okay, so they're asking for this 2 ohm and this should have been 12. We're going to leave it at 2 ohms. That's what they want to know. What is the current through them and what is the voltage across them? That's all they want to know. So how far are we right now? Well, this 2 ohm is actually part of our 1.33. So we know the voltage across these two got to be the same. And you figured out the voltage across the whole combination. Okay, so hopefully you're seeing that the way to do this is you have to go backwards and break things up. And I think I've written these down a little bit too small. Would have been easier if I did it much bigger. So let's continue here. All right, so I have here 1.25 going up through this one and 2.25 current going down through this branch here. So the voltage is Relatively straightforward. It's just the current times the voltage. What? The current times the resistance. I'm not saying the right words. The voltage is the current times the resistance. So I've got the current and I know the ohms, the resistance. So the voltage is just going to be V is equal to I times R. So we take 1.25 times 3. 1.25 times 3. So I've got 3.75 volts. Hard to write down here. 3.75 volts across this 3 ohm resistor. Okay. And the same thing over here, V equals IR, 3.75. Plus minus 3.75. All right. Now, I can do the same thing down here, or I can realize, well, this voltage plus this voltage, 3.75 plus 3.75 is 7.5. I know I've got 7.5 across this whole thing. All right, so let's do the voltage down here. I've got 2.25 amps times 1.33. If it's 1.33, yeah, 1.33. So what do I have here? 2.25 times 1. I'm going to do 1.333. I got 3. That's 3. So here I have 3 volts across this 3 ohm resistor, a 1.33 resistor, which is the parallel combination of these two. All right, let's go to the 2 ohm resistor here. Same thing, the current goes through 2.25 times 2 ohms. And I have 4.5, so I have 4.5 volts. Notice that this 3 volts plus the 4.5 volts is 7.5, which is what we have here at 3.75 plus 3.75, also 7.5, because the voltage across here is going to be the same. All right, so this was one of the 2 ohm resistors that they actually asked about that I have here in pink. So we just figured it out. We know exactly how much current is going through there. It was 2.5, right? 2.25 amps is your answer of that current of that one. And the voltage across it was 4.5 volts. Okay, so that answered that one. Okay, now we got to ask about this one. Well, let's go back here. So I know that the voltage, I know that the 1.33 is actually the parallel combination of these two. And I know that the parallel combination means the voltage is the same across them. So I know that the voltage is 3 volts across this combination. So I have 3 volts on this combination. 3 volts. If I know that the voltage across the 2 ohms is 3 volts and the current is the voltage divided by the resistance, so it would be 3 volts divided by the 2 ohms, which gives you 3/2 or 1.5. So I know the current going through here is 1.5 amps. Okay, so what I'm going to do for you guys is I actually have the solution to this one all done nicely here, maybe nicely, I don't know how nicely, that I wrote up for you, and I'll post that solution that I hand wrote this one because I did it correctly with the 12 ohms. Okay, so again, let's look at what we did here. We had to look at the circuit, immediately recognize who's in parallel. So these 2 6s are in parallel. This was supposed to be 4 and 12, but I had wrote down as 4 and 2 here, unfortunately. And those were my parallel combinations. Then I reduced that. I had 3 ohms in series with this 3 ohm parallel combination. Same thing over here. I had the 2 ohms in series with this combination, which we determined is 1.333333 ohms. And then I noticed that they're in series to each other. So I further reduced them down. And that series combination is in parallel with this series combination. And that's how I figured out exactly what the total current is going through and from and through the power supply. Then we go backwards. We go backwards to figure out exactly how much current goes through each of the resistors and how much voltage or the potential difference is across each of the resistors. All right, so I'll post the solution for the 12 ohm ones. Please let me know if you want to get together for any help. All right, see you next time.